So hey everyone, in this video we are going to deploy our backend application to AWS. Alright, so particularly in AWS we are going to deploy on EC2, or you call this Elastic Compute Cloud, okay, which is basically a virtual machine which when we deploy it will be accessible by the entire world. Okay, so basically nobody can access our backend directly. Usually we integrate that with a front end, and through that we will be hitting our backend. Okay, so whenever we deploy front ends also, it should be publicly hosted, right? So that is why we might want to deploy even our backends so that all of our APIs are publicly accessible. So far we have already been writing our code locally, and we are only able to access it within only our system. Okay, or at least whenever we are connected to a Wi-Fi. So basically we have a Wi-Fi here, and whenever we are actually accessing this particular router and we host this particular code locally, any other person who is connected to the same Wi-Fi, okay, so basically this user here will be able to access our code. Okay, that is basically due to a concept of IP tunneling. Okay, so using this we can trace our IP and get into this particular machine that is running on port 8080. So if I run 8080 from my any other person's laptop, will be able to access my this thing. If you permit them, then anybody else can actually access it. So far we have been discussing about self-hosting. Okay, basically only me and my basically colleagues or anyone who is actually connected to the same Wi-Fi will be able to access our network. Basically when you go to your colleges, and basically if you want to like host a particular project where everybody in your particular campus who's connected to the same Wi-Fi network should be able to access, then this particular approach is completely fine. You can save a lot of cost, and as long as your application is running, everybody will be able to access. Once your application goes down, so basically you turn off your laptop, so nobody else will be able to access it. So that's the only drawback. So basically what is the difference if I locally host this or I host it on the cloud? So basically this is a virtual machine which we call it VM, or you can just also call this cloud. Okay, so these are all the same constructs which we actually interchangeably use. So what is the difference? So here when we do self-hosting, the IP is private. Only I will be able to access it, or anybody connected to the same Wi-Fi network will be able to access. But what about people from any other place? If they want to access our particular application, will not be able to access it because they cannot trace our IP and reach our particular application. So that is where these cloud providers like AWS, GCP, Google Cloud Platform by the way, and also like Azure. So these are all called cloud providers. Okay, so they basically provide something called as an public IP address. Okay, so using this public IP, let's say 1.2.3.4, using this particular IP, I will be able to if it is hosted basically in this particular IP address on port, let's say 8080, they will be able to access my application in any part of the world. Okay, so just because my IP is public, they will be able to access. So that is the difference when it comes to hosting it locally and deploying it on cloud. Basically you say that I want to host this locally and take this public. Of course you can build your own servers as well. Basically you need a lot of maintenance. Your system should be 100% available. It should never shut down. Okay, once it shuts down, then nobody will be able to access your application. So one thing is maintenance, and one is the infrastructure. You need to have perfect power supply. If power supply goes down, if your server also will go down, right? So that time nobody will be able to access your application. So we need to make sure that servers are forever running. So all of these stuff we cannot do, right? So we cannot keep constantly monitoring our servers if they are active or if they are not. So all of these things will be provided by these cloud providers here. Okay, so they will assure 100% that our servers will be forever running, and there will be not causing no inconvenience. Okay, and for every service they provide, they also charge you some amount of money based on the size of the machine that you're buying. Let's say you're buying a machine that has 2 CPU, 4 GB RAM, and 2 GB storage. So these are all the specifications that they provide. So if you want more specifications, you will have to pay more. All right, based on our application requirements, we need to choose the right virtual machine for our application. So I hope you understood by this architecture why do we deploy it on cloud and rather than self-hosting it. So basically you might have a question that if I'm hosting my application in India, will any person from US be able to access our application? Yes, they can be able to access, but with a lot of latency. Let me explain why. So let us consider this to be our world map. Okay, so sorry for this bad writing. So let's say this is a person from America will want to access our server from India. So we'll be able to access, but with a lot of latency, as I told, because there will be a lot of underground cables and wires, so that will actually connect the servers from different parts of the country, the different access regions that our cloud providers actually have. So that is why I just don't host my application in just one particular city. As long as there are users from all over the world, I should also deploy my application in their particular region. So let's say in America there is a server over here, so basically why should I go through the underground cables and then reach my particular server in India, which is actually causing a lot of latency. So that is why I create different points of presence, or you call this POPs. Okay, so we can host our application there, and whichever the region which is the nearest, it will go ahead and access that particular region. So I can host one in India, one in America, one in UK, or one in Singapore, or one in Australia, and so on and so forth. So these are called as points of presence. So if you have users only in India, so you can just host it only in India as well. Okay, so this is the concept about hosting. Okay, so basically I told you whenever we host an application, we get a public IP address. Okay, so let me just erase this. So if I buy a virtual machine from AWS with some specific configuration like 2 CPU, 4 GB RAM and 2 GB storage, they will give us an IP address. So they will just cut out a particular portion of their server and then provide it to us. So we own that particular the cutout portion of that server. So that server will actually have an IP address. So let's consider the IP address to be 1.2.3.4. Okay, so now using this IP address, I will be able to access my application, whatever is hosted over there. So by default, it will go to port 80. Whatever is running, that will be displayed on our screens. So this is basically the URL. If you just go and search this on Google, you will be reaching your particular application. But this seems very ugly by typing the IP address. So if I give an example, if I give you the coordinates of my particular location where I am, if you want to meet me, will that actually make sense? Or I give my actual location, that is if I am staying in Kormangala in Bangalore, so you will be able to understand, right? So instead of just giving coordinates, this is just like giving coordinates. So how would it be if I give my own domain name like todoapp.com? Okay, so this is the domain name which also we need to actually purchase from some service provider like GoDaddy or something, and we need to ensure that this points to our IP address. So if anyone visits todoapp.com, they will be able to reach this particular IP address and reach our application. Okay, so that is the always better approach. So this is how we provide domain names to point at this particular IP address. So in case if you go to like google.com, if you do a ns lookup within your terminal, so you will get the coordinates of Google, like let's say 7.8.9.0. so this is the coordinates of Google. So if I take this particular IP address and go to search engine and search for this, it will open Google. Okay, so I hope you understood the concepts of hosting and domain. So now that we have understood all the basics, let's go ahead and deploy our backend application on AWS EC2, so basically the virtual machine, and try to view our application. And then later we will be using a more sophisticated approach. So currently I'm going to show you without Docker, and then later I'm just going to deploy it using Docker. All right, so let's get started. All right, so now let's go to AWS and then create an account over there first of all. So I'm just going to type AWS here and going to the official page right here. So you can go to aws.amazon.com, and if you don't have an account, you can just right away click on create account. And one thing I would like to say is, in order to create an account, you need a credit card. All right, so without a credit card, you will not be able to create an account on AWS. All right, so make sure while signing up, you will require a credit card. All right, so you will not be charged for anything per se, because as in future, if you are using some services and some charges incur, in that point of time they will make use of your credit card. All right, so don't worry, you will not be deducted for any amount. Always make sure whenever you are running any service on AWS, always use shutdown after experimenting that particular service. All right, so after I create a EC2 machine, I will terminate all of the instances so that any charges will not incur for me. All right, so since I already have a account, so I'm just going to click on sign in to an existing AWS account. Okay, so I'm just going to click on sign in with root user. So basically there are two types of users. One is the root user, which is actually the administrator role for your particular account, and also you have an IAM user. Basically you will assign users and restrict particular roles and policies for that particular user. So since I'm the root user, I'm just going to sign in with that. So once you sign in, this will be your landing page, basically your dashboard. So if you have any applications running, so it will be displayed over here. All right, so make sure that whenever you're using any service, if you have an application running, make sure you terminate that as far as you're using this AWS account for learning purposes. All right, so currently we are interested in creating a virtual machine, right? So the name of the service that AWS provides for creating virtual machines is EC2. Okay, so we can just go to the search and search for EC2. So it says virtual servers in the cloud. All right, so this is the dashboard. So if you just go to the home of this, you'll see an interface like this called as Amazon Elastic Compute Cloud, also called as EC2. So we can just click on launch instance. Okay, so here we just need to give it our configuration, and based on this configuration it will cut out certain specifications and create a virtual machine, and especially it will provide us with the public IP address which we can access and deploy our particular application to that particular machine which is present in the cloud. So we can just give this name of our application. So I'm just going to call this to do app, and this should always be unique. So I'm just going to give this NBA, which stands for Node Backend Architecture. All right, and next we need to select the type of operating system that our virtual machine operates on. All right, so there are various operating systems. So usually the ideal operating system is we choose Ubuntu, okay, which is OS of Linux. Okay, so there are many advantages of using this in the cloud. It is lightweight, and it is of course open source, and there are few things that is already installed within Ubuntu itself, like for example Git. All right, so we don't have to separately install that. So rest we can leave it as is. So we can, if we scroll down, now we have this particular section called instance type. So here we just need to select the type of the machine, okay, which has this particular specification. So you see that this is a very long list, and based on whatever you select, it will cut out the specifications and provide you the virtual machine. All right, so it varies from the smallest of machines to the largest of machines that you could ever see on a cloud. Okay, so the smallest is like T2 nano, and then it goes all the way up to maybe like T3 large or T4 2x large, and so on. Okay, for our application, just for the sake of demonstration, we can go with T2 micro, which also says free tier eligible. So these are the specifications. We just have 1 core vCPU, 1 GB RAM, and these are all the pricing based on the operating system which you have actually chosen. All right, so I'm just going to select this. Okay, and here we have a key pair login. Basically it will generate a new key pair, okay, which is in the form of a PEM file. Okay, so basically it will allow us to download that particular file, and using that particular file or key pair, you will be able to connect to your virtual machine on AWS. So ideally you need to choose this particular option, okay, so where you have to generate a new key pair. So if I click on this, it will download a key pair, and we need to make sure that this is always secure. Otherwise, if this gets leaked, then anybody can log in to your virtual machine, which is your particular account, and they can operate. They have complete control over your system which is on the cloud. All right, so always you need to make sure that this is completely secure, and make sure you don't share it with anyone. All right, so just for the sake of the demonstration, I'm just not going to do this, which ideally you should. So I'm just going to go with a without a key pair. Okay, basically I can log into my AWS account and use the built-in terminal to access my virtual machine. And the next we have is network settings. Basically we just want to limit certain IP ranges to access our virtual machine. So if there is somewhere else who's trying to access our particular instance, so it should get blocked. Okay, so this is basically for security reasons. All right, so you can just go through one by one, and currently I'm just going to set this to access from anywhere, which means that anywhere in the world I can access my virtual machine. All right, so we can leave the rest as is and click on launch instance. Okay, so this is going to take certain time. All right, so maybe like 2-3 minutes. So you can just click on this instance ID and this will take you to the list of instances that you have. So currently it is running. Okay, so now our virtual machine is successfully set up. All right, so you can just click on this particular instance and view all of these details. And the main thing which we need to now see is this public IP address. Okay, so this is our IP address which we can actually visit and view our application. So currently there is nothing, so we just need to SSH inside this IP and we can access our basically system inside virtual machines. Okay, so you will not be given a user interface just as how I'm operating this particular laptop. So you will only be given with a terminal. Using the terminal you will have complete control over your virtual machine. All right, so this is my public IP address and this is the instance ID and all of these stuff. This is my subnet and yeah, that's it. So this is the public resolved DNS basically given by default by AWS. So if I just copy this and if I just try to open it, this will actually not open because there are some firewall settings. Okay, or there is some port restriction, so this will like keep loading forever. So we just need to also configure that. Okay, so now we want to connect to our virtual machine using the terminal, right? So you can just click on this connect, and then if you just click on connect, it will open a terminal inside a browser like this. Okay, so if you see something like this, like Ubuntu, basically this is our operating system and this is the IP address. So this is our terminal inside our virtual machine. So if you just try to access the file system, there is currently nothing. Okay, so this is completely empty. So this is a new computer which is already hosted and anybody in the world can access this particular IP address and view your application. All right, so that is the biggest benefit of hosting our applications on the cloud. And of course we need to provide certain security rules such that this particular IP ranges should be able to access this and rest should be blocked. Okay, so you just don't want anybody to actually access your IP. Okay, so just for security reasons I have just told you that. So now it's the time to install Node and all of the dependencies that are required for us to run this particular project on this particular terminal. All right, so first thing is we just need to install Node. So now we can just Google how to install Node on an Ubuntu machine. Okay, so install Node Ubuntu. Okay, so basically this is a good post actually, so which will actually install all the packages that are required. So we can basically follow this particular command using the Node version manager. So if you just copy the steps and execute one by one, we will be able to install Node. Okay, so we can just copy this particular command and paste this within our virtual machine terminal. Okay, so I'm just going to wait till it installs this nvm. So once that is installed, we can now go ahead and apply the changes. So by basically doing source dot bash rc. So I'm just going to copy and paste that over here. So now that our changes are applied, so now we can just go ahead and install Node. Okay, so now you can verify if nvm is actually installed or not. Okay, so if you see some commands, list of commands like this, which means that it is successfully installed. Now we can just finally go ahead and do an nvm install Node. Okay, so basically this is the most simplest approach in order to install nodejs in any Ubuntu machine. So let's wait for it. Once it's done, so it has now completed installing. So if we just type node-v, which will give us the version. So this is the latest version, which is running on version 24. All right, so now let's go ahead and basically git is already installed. You don't have to just do npm install git or something like that. So you can just access git just like that. So if I just do git, you will get some commands like this. So git is by default installed within Ubuntu, so you don't have to install that. So we can just do a git clone. First we want to clone the repository. So this is my actual repository. So if I want to clone, I just need to copy the URL, right? So if I copy this and go back to my terminal here and paste this over here, so this will go ahead and clone all of my code. So you can just verify by doing ls. So it has pasted inside this folder called Node.js backend architecture. So we can just cd inside this particular thing, and over there you will see all of our packages or all of our source code present inside that. All right, so now we can do a npm install to install all of the packages. So remember that we are using pnpm, right? So to install pnpm, we can just do npm install -g pnpm, and this will install pnpm. So let's wait for it, and once that's done, we can do a pnpm install. Alright, so now all of our packages are installed. So now we just need to run the server. Okay, so currently we just don't want to do a npm run dev. Okay, so that will give a development version of our application. So that will contain most of the things that are not required when it comes to production, basically when the end user should actually be viewing it. All right, so we need to run the production version of our application, basically when we compile all of our TypeScript code inside the dist folder, right? So that is the actual folder that needs to be served. All right, so for that we can compile all of our code by saying tsc-b. I'm not sure if this command is actually available, so this is not available, so we can just do a sudo apt install node TypeScript. That's what it's suggesting me. And once that's done, let's verify that again. Okay, so we just did that. It can be installed with this. Anyways, let's do a npm install -g to install it globally. So I'm just going to install TypeScript. So once that's done, we can now try this command again. So that should succeed. All right, so let's wait for it. So this should actually create a dist folder based on the tsconfig file that we have. So we get some errors here. So we are getting a bunch of errors. All right, so this is the exact same code which I am actually running from my local machine, and it is working completely fine. Okay, so whenever I try to compile all of my TypeScript code, it is giving me some error. Okay, so this is the main motive of using something called as containerization, and you see that this is a completely different environment when compared to the environment which I am running to run this code. So this is running on Ubuntu, and the code which I am running locally is on Mac machine. Okay, so that has completely different specifications, and this has completely different specs. So that is the reason we are getting all of these errors. So since yesterday I just tried a lot to resolve all these errors, but these errors were actually not going. So that is the reason why we need to containerize our application before we actually deploy, or before we even run this on a completely different operating system. So now let us go ahead and understand how can we deploy our backend application using Docker. So now I am going to show you a more sophisticated approach of deploying our backend applications using Docker. All right, so this is basically without Docker, which we have done so far. So now I'm going to show you the sophisticated approach in order to deploy any kind of backend application to the cloud. All right, so that is by containerizing our whole application and then deploying the container itself and running a task based on that container. All right, so far we have seen an approach. We already saw the problem if we try to deploy without containerizing our application in a completely different environment. Now we are just going to deploy that using Docker. So there are a couple of steps which we need to configure inside AWS in order to deploy our application. First thing is we just need to register our container inside a service specifically in AWS called as ECR, which stands for Elastic Container Registry. Okay, the name itself says we need to register a container. All right, so we can just search for that service ECR. Okay, so it says Elastic Container Registry, and yeah, so here share and deploy container software publicly or privately. Okay, so we can just click on create, and we can just give this a name. So I'm just going to call this to do app NBA, so it stands for Node Backend Architecture, and then we can click on create. All right, so this is successfully created a registry. So all we just now need to do is, so if we go to our repository, all right, so currently we do not have any images. Okay, so in order to push an image to ECR, we just need to follow some particular commands that AWS itself provides us. Okay, so if you just click on this view push commands, so these are all the steps what we need to do in order to push a particular Docker container inside this particular registry. All right, so first thing is we just need to ensure that we have AWS CLI. Okay, in order to interact with the AWS within our AWS account, first thing is we just need to log in and provide a password. Once we are logged in, then we just do the pushing process, okay, where we push our Docker images to this registry. And once we push over here, we just need to move on to the next step, that is by running a service. All right, so let us complete this first step, which I'm just going to copy this particular command. And we also need to make sure that we are having the AWS CLI. So in order to download AWS CLI, so you can just type AWS CLI, so whichever operating system you're on. So I'm just using mine for Mac, so you can just go to this link and download the CLI. So here, based on your operating system, you can just select the appropriate option and download it. All right. Or if you are on Mac, the one thing which I actually found it useful is by installing using homebrew. Okay, by saying brew install and then the package name, that is AWS. Okay, so that's how I installed. So now in order to verify, you can just go to your terminal and just type AWS. You will find some particular commands. All right. So let's go ahead and test that. So within my VS Code terminal, so I can just verify by saying AWS. Here we are getting something like this, which means that it is actually successfully installed. If we get an error, that means there's something went wrong. So now let us go ahead and copy this first command and give it a login. All right. So this is going to log in through our username, which is encrypted within this particular link. So let's wait for it. And now it says login succeeded. Now let's go to the other command in order to build all of our files inside this particular tag, that is to do app nba, because this is the exact name that we actually provided while for creating this registry. All right. So let us go ahead and paste that command here. And before you paste, make sure that your Docker daemon is actually running. So let me just turn that on. So now let's start the build process. So let's wait for it to complete. So it took about 2 minutes for me to install this. Okay, so once the Docker build process is completed, we can now go ahead and tag this by copying the next command. And once we tag this, we just need to finally push this to our Docker registry inside AWS. So let's copy the final command and let's push this. Okay, so let's wait for it. So it says pushing, and it has like about 300 to 400 MB of files. Okay, so now we have successfully pushed our Docker image to ECR inside AWS. So now if we just give this a refresh, we should be able to see an image. All right. So this is by the tag, by default it is latest. So basically, usually we give version numbers. Okay, while building our application. So as any changes we make, we just increment the version number. So that's an option there. So it has like about 107 MB, so it's a lightweight image as well. So once our image is pushed, we just need to move on to another service that is used to run this particular container that we have registered here. So that is Elastic Container Service, or ECS. So let us search for that service over here, and now we just need to again click on get started. And this, first of all, we just need to create a cluster. Okay, so a cluster is basically a bunch of services it actually runs, right? So basically a service is linked to a task, okay, which will indeed run a particular Docker container. All right, so I just want you to just understand that a cluster will contain multiple services and each service will run a specific task. All right, so the first step is to run a cluster. So you can just click on create cluster, and here we just need to give it our configuration. Let's give this cluster name like to do app cluster, and then we need to select our infrastructure. Okay, so currently we have two options. One is the EC2 approach, which I already showed you in the previous section. So this time we are going to use the serverless. Okay, basically the only difference is in EC2, this is also actually a virtual machine, but this is pay as you go. Okay, so if you don't have any users or any visitors to your particular application, so your application will be on standby and it will not be running. Okay, so when user comes, the application starts running. So by this you save a lot of cost. Okay, but when it comes to EC2, this will be running 24/7 regardless of how many users visit or your website or not. Okay, so that is why we could go with the serverless approach. So now we can just click on create, okay, by leaving this as is. So let's wait for the cluster to spin up. So now we have created our cluster. So currently there are no services running inside that. So the first step before we actually create a service is to run a task. Okay, so we can just click on task definitions on the left side and click on create a new task definition. All right, so this is the particular task will basically run our Docker containers or Docker images and spins up containers. Okay, so how many containers and all of that we just need to provide within this specific configuration. Okay, so let us give this a task name. So I'm just going to call this to do app task. All right, and here again we select the Fargate, which is serverless, and here we just need to select our operating system which it has to work on. So we can just leave it to Linux. So in the previous, while spinning up an EC2 instance, there also we had set up our operating system, right, like Mac OS, Windows, or anything else. So we can just leave this to Linux. We are good with 1 CPU and 3 GB memory. Anyways, this is just for testing. Later we are obviously going to delete it, and now we just need to give it our container specification. All right, so here we can just give this a container name. So we can just call this to do app and give this a URI. Okay, so remember we had copied the URI, right? So we can go back to our ECR and copy the image URI. So here you can just copy this URI and just paste it here, right here, and then we just need to give this a container port, which is on which port does this has to be running. So that is 8080. So this will open a port basically and block any other ports for security reasons, and here the protocol is HTTP, and we can just leave this as it is. So if you have any other ports that is running inside our application, you can just click on add port mapping and add that. All right, and then we have this environment variables, which actually we have contained inside our Docker image itself, the .env file, so we don't have to configure here. And these are basically to capture your container logs. We'll create another service called Amazon CloudWatch. So ideally we just need to enable this, and in order to capture your logs. And one more thing which I would like to add is this health check. Okay, so basically whenever it just keeps monitoring our particular Docker container if it is healthy or not. Okay, so there could be any specific command that we run that would actually crash our server, or the process might get killed. Okay, so in order to check that, we can just provide a health check. Okay, so basically whenever our server goes down due to an unexpected error, so that time when we try to make a request, so it will not go right, so we will not get a 200 status code. So in that case, so we just need to run this periodically, like maybe after every 1 hour, to check if our container is still healthy. If it is not healthy, then it will just delete the old container and start a new container. All right, so that is the route which we need to specify here. So I'm just going to put this to curl -f. So this is the endpoint that it will hit, so that is /. Okay, so if we go back to our code level and we just try to check what is running within localhost /, so it is right here. It will just return this with a hello world. So we get a 200 status code. Okay, so the time we need to configure within the service level, okay, and not within our task. Okay, so for the task, these are the configuration that we need to give, and we can just finally click on create. All right, so let's wait for it, or it just created. So you can just click on view task definition, and this will take you to that. Okay, so this is our task definition, and you can just go through it one by one and what exactly you have specified for running the particular task. You see that this is the container, this is the container name, and this is the image URI. All right, so now that our task is actually configured, we just now need to run a service based on to run this particular task. So now you can just go back to your clusters and go to your specific cluster, and over here you see a section for services. All right, so you can just click on create. So over here we need to specify our task. Okay, so this is a drop down of giving us a list of tasks. So this is the exact task that we just created. So we can just leave this environment as it is, and this is the deployment configuration which we need to specify. Okay, so we just need to specify the number of desired tasks, basically the number of containers it should actually run. Okay, so based on this number of containers, it will actually load balance. Okay, so it will also create a load balance under the hood, and any request that comes to the load balancer will route the traffic in between these two tasks, okay, or these two containers which is actually running. So currently by default it is 1. We just for testing we can just set this to 2. All right, so we are running 2 containers. And also if you remember, we had also created a health check, right, which will periodically check the status of our container. So we can just leave this to 30 seconds. Basically every 30 seconds it will check the status by hitting that particular API which I actually showed you over there. All right, so the next step is this deployment option. So for the deployment type, we can just give this as rolling update, which means that like for example, if a container goes down, so in order to bring a newly different container backup, so it will just make sure that once the container the new container is brought back to a healthy state, it will delete the container that was failed. All right, so that's the rolling update. So if you just go down, we have the networking section. Okay, so we can just leave this as it is. So if you want deep level of configuration based on your application, you can just go ahead and do that. So this has a couple of subnets which it has to work upon, and the security group, so you can just give this a security group. And here we need to enable load balancing, just as I told you, for the two tasks that we are running, so it has to load balance between them, right? So we can just enable load balancing, and we can use the application load balancer. Okay, so to this particular container which is running on port 8080, and here we want to create a new load balancer, and we can just give this a name. So we can just set this to do app load balancer, and here we just want to listen to the specific port that is running on port 8080, which is HTTP, and here we just need to give this a target group. So we can just give this a target group of to do app tg, and yeah, so now we have configured our load balancer. All right, the next step is to configure auto scaling. Basically we are currently having like two containers that are running. So in case there are a lot of traffic that is coming inside our servers, so we need to horizontally scale it by spinning up multiple containers. All right, so we can just give that a specific limit. Like from currently we are having two containers, so it should span all the way up to maybe 10 containers. So we can give this within this auto scaling section. So here we can use select use auto scaling, and the minimum number of tasks which we want to run is 2, that we have already set up. Okay, and the maximum we can give this to maybe 5, or let's give it 10. So now we can give this a policy name. So we can just say to do app policy, or policy, and here we can give this a metric. Okay, so on what basis do we want to scale up or scale down the number of tasks? Okay, so we can just select the average CPU utilization. Basically, if the average CPU utilization goes like above, let's say 50%, then we want to scale up, we want to bring a new container up. Okay, or we want to run a new task in other ways. All right, so we set that to 50, that is if it is going more than 50% of CPU utilization, then we want to spin up another container. All right, so that is it. We can leave the other options as it is, so can click on create. All right, so this is going to create a service based on the task that we had created. So this might take some time. Okay, so as it says, takes few minutes, so let's wait for it. Now our containers are up and running. You see here we are getting 2 tasks running, 2 out of 2 tasks running, because 2 was the minimum task that I set in order to run. Okay, so whenever our CPU utilization goes above 50%, it will scale up. All right, so currently 2 are running. You see that both are healthy, and this is the load balancer that we had just created, which will load balance between the 2 tasks that we created. And when you go to tasks, you see that these are the 2 tasks. Okay, so currently it says unhealthy, but I don't know what is the reason. So when you just click on one particular task and just check the logs, so you will see that our containers are running. It should say that server is running on port 8080. So one thing we need to make sure that whenever we are creating a service, so let me go to update service. Whenever we are building our Docker image, which are the OS, which is currently I'm on Mac OS, which is running on ARM64. So we need to also select Linux ARM64. All right, so previously I hadn't select ARM64, so that is the reason my deployments were actually failing. So if you have built your Docker image using ARM64, that is the operating system, then we need to select that. All right, otherwise you can go with the normal one. So with that change made, all of our tasks are successfully running. Okay, so now we can just go ahead and test our application. So if we just go to this service, and we can just go to this load balancer, which should have an IP address assigned to it. So over here, which is says DNS name and a record. So if you just copy this and go to a browser and put port 8080, because that's where our application is running. So you see that we get hello world. Okay, so this is the exact message which we had actually printed when we go to just the root. Okay, so this is what it returns. So this is what is actually being returned. All right, so now we can go ahead and test all the routes if they are actually working. So I'm just going to copy this particular URL and go to Postman, and over here I can just replace this URL with our actual URL, the load balancer URL. Okay, so now we can just try to register a user. So we should be able to register. All right, so it says user already exists, which means that we are getting some response. So our APIs are actually working. So let me just try to register with another user and just check. Yeah, our user is now registered. So we can just go ahead and try to create a to do. So I'm just going to copy the same URL. So /API/to do, replace the URL here, and now click on send, So we get the to do. All right, so sorry, our to do is now created with these title and description. So we can click on now get all to dos. So if I replace the same URL again and click send, so we are getting the response. Okay, so again if I click send, because currently now our Redis is not running, okay, so we cannot expect that things to be cached from Redis, because that we need to create another service and use it within our backend application. So we cannot run Redis locally since it is now deployed on the cloud. We need to buy a service provider and then link it up with a backend application to actually use Redis, but that actually requires a credit card, which I am currently not going to do. Okay, so I hope you get the idea behind what we are actually trying to achieve. So this is all about this particular video, how you can actually deploy your backend applications on the cloud, particularly in AWS or any other cloud provider. So currently I have shown you the approach how you can deploy on AWS. Okay, so the same approach, when we try to migrate to some other cloud provider, the same configuration will not apply. Okay, so other cloud providers will have different services and they won't have like AWS Lambda or EC2, so they have their own services. Okay, so that is the problem. When we want to try to migrate to another cloud provider, we will be having certain issues. Okay, so we want to set up again and again. How will it be if I just have one config file and it has all the rules written, like how many tasks it has to run, and like when our containers go down, how it has to come up, all the deployment process within that one file, so it can work with any service provider or any cloud provider. All right, so that's where the concept of Kubernetes comes into picture. All right, so in the next video we are going to understand how can we use Docker in conjunction with Kubernetes and how that can help us in deployments. All right, so I'll see you guys in the next video.